students who were able to make it, they can see the recording. So let me just test out. Okay. Can just someone just come off mute and say something so I can make sure the stream captures any questions?
Testing, testing. Can you hear me?
Yep. All right. Everything is coming up. And YouTube is good to go. Okay, I'm gonna share my screen, Robert, and then we can get started whenever you're ready. I think we have everybody in.
Yeah, I think we're 5 minutes in, so we can get started.
Cool.
Yeah, so everybody can watch the screen. I'm gonna raise my desk a little bit. Give me one.
Okay. All right, looks like everybody can see. And we're good to get started. All right. So, welcome to Solidity ATL's first Web3 security session. Just for starters, we're going to just run through this agenda really quick. So for this session, we're really just going to introduce ourselves so that you know who we are. We're going to talk about some careers in Web3. We're going to touch on the value of auditors in the space. And then we're also going to talk a little bit about thinking like an attacker. How do we put ourselves in the shoes of an attacker? And then lastly, we're going to round it off with some assignments and some capture the flags we can go ahead and get started with together. So just a little bit about myself. I'm a MIS grad, that's Management Information Systems. I graduated from Texas A&M University, and afterwards I jumped into technology consulting. And so this is a lot of business and tech experience where I was working with dev teams and trying to hit targets for whatever projects we were working on at the time. Shortly after I joined into the technology consulting space, I decided I wanted to jump into CTFs, and I started learning how to do traditional Web2 hacking. And that just got me hooked from being a hacker from the start. And so I switched my career to do security consulting. So I became a security analyst at Accenture. And then from there, I jumped into Web3 security, and I haven't looked back since. I jumped into Web3, started doing some blockchain pen testing, and I've been auditing smart contracts for a little bit over a year. If you haven't already, feel free to follow me at Wizard Kelly. I post some stuff about Web3 security and just a lot of training material.
Cool. As before I go into myself, just want to make sure if anyone has any questions, you can post in the Discord chat as we're talking, and we're gonna be periodically asking for questions as we go. So hi, my name is Robert. I study physics at Georgia Tech. Been a software engineer for 7 years. Currently work at Open Zeppelin, mainly working on the forwarder protocol. I've been in Web3 for over a year and a half now. And in terms of hacking, I guess I've always been a hacker because I used to do a lot of my work before involved both software and hardware. And so I would hack the company I work with, their devices to make some of the things work. So I've always had that, how do I break things mentality? And once I learned that was something you could do for smart contracts, yeah, I was hooked. So I'm excited to teach what I know and hopefully also learn as we go through this.
Nice.
So first wanted to start before we go into the security. This course, we have 5 sessions, and before all the other sessions are going to be mostly around auditing, security, those details. But want to take a step back and first go through what a career in Web3 can look like, not just from the technical perspective, but what are the different things. So the image on the left there, ignore the metaverse developer. I don't know what that is. I was just trying to find an image that has some different things. But there are multiple different engineering developer roles, both front end, back end, full stack, smart contract. But there's also non-developer roles such as designers, community managers, product managers, tons of roles there. The image on the right there is showing more of the organizations that may exist within Web3 companies. You see engineering and data science are the two technical there, but there's others as well. There's product roles, there's sales, human resources, legal. So there's a lot of different career paths in Web3, not outside of engineering.
Hmm. And also, wanted to add that I've worked with people who were in some of maybe like the non-technical areas of Web3, and they didn't have, too much knowledge of Web3. They were, beginners. They were people who had just transitioned their career, and you're still able to succeed and thrive in the Web3 space. So I just wanted to also just share that, no matter what stage you're in your career, you can transition to Web3, and you can always continuously learn about, the blockchain and the technical things along the way. Okay.
So these next couple slides kind of, uh, I guess, they kind of break down a narrative of how I understand the demand, specifically for technical talent. This report here, I can't remember the name of the group. I have a link to the source in the slides, but they're a large financial institution in London. Um, and they wrote this like 130-page report breaking down the trends of crypto. I think their data stops like mid 2022 or late 2022. Um, so on the bottom left-hand corner there, just showing overall investment in blockchain companies. I haven't been able to get good data on 2022 and 2023 yet. And I just wanted to show that because even in a bear market, the current investment rate is still much higher than it was in 2020. Um, that figure on the top right there, so the number of cryptocurrencies that have been created over time. And the way I think about that as an auditor is the more protocols that exist, the more need there is for protocols to have auditors help them with their security. And that chart on the bottom right there is showing the growth in employment. I have some more data on the next slide that shows a little bit farther into late 2022, where you do see a decline, but there's still especially for um, technical talent, there's still far much more of a demand than there is a supply. And that chart there on the bottom there is kind of just showing how those jobs are distributed, where you see about 65% of them are technical, and like half of that is developers or security professionals.
I think to add here is even in the Web2 space, cybersecurity professionals are at a huge, huge, huge demand. Even in, I guess we can technically call like a recession, though we're in a recession, there's still a lot of positions available, still a lot of apps being sent out, a lot of recruiters reaching out for security personnel. And that's just in the Web2 space alone. And so this does translate into the Web3 space. We definitely need a huge, huge help with the amount of security people that are in this space. So,
Cool.
you can go ahead.
Oh, I was just gonna say, yeah, we just wanted to start focusing in specifically on auditors because that's what we're going over in this course. Um, just as I mentioned, the demand for just like general Web3 talent is high. I think auditors is one of the highest demands. And I think Miles can speak a little bit more on that.
Yeah. So just jumping into this one, as Robert said, there's more protocols that are entering the space. A lot of funding is jumping into this area, and so there are new developers who are building these protocols and launching them. And before you deploy to mainnet, you want to make sure, or they want to make sure that they have their contracts audited. And so from this perspective, while you usually receive an audit before production release, you also would receive, it's a best practice to receive periodic audits. So if you make any changes, if you make any updates to the code, you want to get these audited over time. And so an issue right now in the space is um, auditors are booked out to the point where even in a bear market, they don't have the bandwidth to handle the demand of who needs to be audited. So um, as more developers are coming in, writing code and deploying, we need more auditors as well, and we're just not seeing that need being met. So, additionally, as more people are starting to jump into space, we have the government starting to take an eye and starting to jump into this space. We have more funding starting to jump in. Big money is really starting to invest in the Web3 space, and this is going to be a huge problem as we become bigger, is because more funds are starting to be stolen. If you just have been involved in crypto Twitter and maybe some of the recent hacks, just a few weeks ago, there was a huge hack that just occurred, and a lot of money is being stolen. And so we need to have auditors, we need to have competitions, we need to have all kinds of setups for security folks to jump into this industry and then help protect users' funds.
One way I wanted to quantify how I think about the value of auditors. I was just gonna show a couple of real hacks that happened and a breakdown of the vulnerability. Um, and to set the context here, I guess how many of you are familiar with auto reports? So I guess if you read an auto report before, I know some of you replied in the survey. Could you just press 1 in the chat? And then if you have not read an auto report, could you just type 2? I'm just curious to see where everyone is. Okay. So when looking at an auto report, the way it's usually broken down, and Miles could also help break this down as well. You have different severity of issues. So you could have, issues that are low, medium, high, and critical. And those severities are basically how much of an impact will this vulnerability have if it's exploited. So for example, this vulnerability here, I would consider this I don't know how big the protocol is, but this is definitely at a medium or high, where someone was able to steal $1.7 million. And the root cause of this vulnerability was improper access control, where there was an assumption that it's like someone's mic is on.
I can mute.
Do you mind muting your mic?
Got him.
Thank you. So this vulnerability, basically someone took advantage of the fact that the developers who wrote this function assumed that it was not accessible outside. And on an auto report, this would show up as a medium or a high. So whenever I'm reading auto reports, every medium and high vulnerability is addressing like an attack that could be of this size.
Nice.
And the second hack here is a similar vulnerability, where there was an incorrect validation. So not necessarily access control, but this was basically allowed someone to act as an owner of a contract when they weren't supposed to. This is just another example of, if you find a medium or high vulnerability, if you find this vulnerability during an audit, this will be medium or high. And so every vulnerability that auditors find is very valuable. Miles, did you have anything you wanted to add there?
Yeah, just to add, I want to say, well, for those of you who haven't seen audit reports, some of the mediums and the lows vulnerabilities will be, I think, much easier to understand. What this vulnerability is related to. Even for me, some of the highs that I read currently, I'm like, what is going on? I have to take a second, third, fourth take. So if you're reading these now and you're like, oh, I don't know what that means, don't worry, we're gonna jump into this stuff and kind of talk a little bit about access control. Validating, input parameters. So at the same time, I do want to say that the vulnerabilities we just kind of reviewed are those ones where it's easier to find, and it also has a huge impact on that protocol. So even as someone who may be jumping into the space and you may not know those high level attacks, you may be able to find those medium vulnerabilities that can still have a great impact on the protocol that people may just have passed over because they're so busy looking at something else. So um, that's kind of just a point I wanted to throw in there. To the next one. So what we're going to talk about a little bit is, or actually, let's pause for questions. I know we covered a good bit of stuff. So anyone have any questions? Feel free to come off mute, and if you're a little shy, it's okay. You can throw a question in the chat, and we'll answer them.
Is there a map of all the protocols that you guys audit? Like a
One more
little
time.
Bible of all the protocols?
Oh, like an architecture diagram or like
Yes.
documentation for the protocols. Is that what you were saying? So yeah, that's a great question. Typically before an audit, it's a best practice that protocols have this documentation ready and set up. This is the thing that a lot of auditors talk about in the space is, protocols sometimes don't put a lot of attention and detail to their documentation, and that can really hinder the security of their protocol because auditors need to understand this documentation. They need to read this documentation. But for the most part, it's a best practice to have thorough documentation so that your auditors can come in and understand what they're trying to break. And so I will say right now it has gotten better. And for most of the protocols you see, there is documentation for us to look into and potentially learn how to find some vulnerabilities.
Throw another question here.
Mhm.
So I come from the IP world and the telecom using different standards, and there's organizations that the protocols and stuff. But here in this space, it's like still there's no standardization. I guess that's the hard part to audit where there's no standardization of all the protocols. But that is there something that the community is standardizing?
Yeah, I think one of the main standards are the like ERC20 or EIPs that you see. So like I think you're right. It's still like there definitely needs to be more standards, especially around patterns and best practices. But right now, a lot of the standards are the ERCs and EIPs. So like ERC20 is a standard because before that, it was like there was no definition of like what a token was. And ERC 721, 1155, a lot of those are, I would say, the closest standards that are enforced. But there still needs to be more standards around like security practices and other things.
Yep. Maybe one more question.
I have a
Anybody else?
question.
Yeah.
Mhm.
Um, so I've always wondered, like, how long do you give yourself for an audit? Like, and the reason why I'm asking is like I've done like a couple like audits on Immunify, and like I didn't find anything because like it's not like Code Arena where they're more like there's like low hanging fruit, but some
Mhm.
have where there's none in there. So when
Yeah.
do you kind of get like the like wave the white flag, like okay, there's nothing really, maybe a couple gas things, but other than that, there's nothing really I can fix.
I'm curious on your opinion, Miles, but
Mhm.
I think about it where, and I'm going to get into this more in the fourth session on public audits versus private audits. Because I think the approach I take for public audits, even between like Code Farina and like you mentioned, Immunify, is different. So like for Code Farina, Sherlock competitions, I basically time box like how much time I have to participate because I still work a full-time job. So if I say like, okay, I'm gonna focus on this for 4 days, I'll basically break apart. I would say, hey, I want to spend one day where all I'm doing is reading documentation, trying to understand the code. Maybe I'll extend that to 2 days if it's super complex. And then have another phase where I'm just leaving like bookmarks and comments on areas of the code where uh, not necessarily that I notice a vulnerability, but that I have like questions or maybe I think something would be weird. And then those last couple of days, I really will try and narrow down to find vulnerabilities and get that report. And private audits are a whole nother
Yeah, that's,
way.
Hmm. Yeah, I'm in the same boat. I have a full-time auditing job, so basically what I do is I only have like 2 to 4 free hours in a day, and so I'll give myself a week and say this is going to be dedicated to this one contest. This is going to be dedicated to this one thing, and then I will take that week. And if I find nothing, it's time to move on, go to the next thing. I honestly haven't really started doing Immunify stuff. We can get into why why a little bit later, but yeah, Immunify takes a lot of time to find those vulnerabilities. Like um, it's a high risk high reward type of scenario where people may spend a month finding that vulnerability, but on the other end, it may be able to do like a $200,000 payout. It may be like $1 million payout. So it's just one of those things where if you have the time, then do it. But for me, it's like, okay, I have a full-time job. I'm only going to give 1 week or 2 weeks to this Immunify report, to this Immunify protocol or this contest. That's just how I approach it.
makes sense. Thank you.
No problem. Cool. I think we can go on to this next one. If you have any questions, throw them in the chat, and we'll also have Q&A other parts of this course. So jumping into this next topic is having the adversarial mindset, and what all this means is understanding that if anything has been made by a human, if anything is technical, it can definitely be broken. You know, we're humans, we make mistakes. It can be broken. If you're a developer and you have built something, I guarantee you there's going to be some type of bugs in it. Now, the difficulty of that may be different, but it's likely something there. Um, and so, what a lot of security professionals are taught early on is making sure you have this approach that something can be broken, and then at the same time, understanding that you have to think like an attacker. You have to put yourself in an attacker's shoes and try to figure out, how can I break this? What are all the ways I could, mess up this protocol? What are all the ways I can do some type of damage? And once you start training yourself to think like this every single day, you pretty much have a great approach when you come to ethical hacking. And so, a good, I guess, high level overview of how do you have this adversarial mindset is a few things. Is first, you want to gather as many assets as you can of this protocol or this application you're trying to break. Then you want to grab the actors. Who are the people that's going to be interacting with this protocol? Users are an actor. Developers are an actor. Supply chain, third-party resources are actors in this model. And then you want to gather any tools that can help you gain any information about this protocol or application. And then from there, you're going to map out different data flows. So a developer pushes this data up via GitHub. The application sends data from this location to this location. All right. And that is essentially gathering the threat landscape. And once you do that, you start to perform, that was research. So you start to perform attack scenarios and draft these attack scenarios of how all these things are interacting with each other. And in each of those scenarios, you say, okay, I think this can be broken here. This can be breached here. You can even jump out into the physical realm and say, this can be stolen and this can help me get access to this. And so this is how you think like an adversary. And this is kind of what ethical hackers are trained to do, because black hats think like this every single day. And so to kind of summarize this up, you have to ask yourself two questions when you approach a protocol is, what does this thing do? Make sure you have a good understanding of it. And then how can you break it? And so that's like an intro into, the hacker's mindset and thinking like a black hat.
And one thing I want to mention, our next session, we're really going to focus on the auditing process, and start introducing, because one piece about the piece, how could I break it, is learning how to be a security researcher. And one piece of that is starting to become familiar with the common vulnerabilities, common bad practices, and starting to keep up with, recent attacks. Like one next session, we're going to talk about a vulnerability called access control, like what that is, some examples of that. So that how could I break it part of that is just learning different attack vectors that already exist. And over time, you can learn more, but even if you know a couple, those are the things you can look for during an audit contest. So I just wanted to have that framework there.
Yep. Cool.
Cool. So I think we're going to switch now to be focusing a lot more on Solidity and EVM. So maybe, do you think maybe we could take a 3 or 5 minute break just so everyone has a fresh mind when we go into this?
Yeah. Yep. Take a quick break, y'all. Grab a snack, grab some water. We can also stay in here, ask questions.
Cool.
Yeah.
I'll be back in like 3 or 4 minutes.
Cool. So I do see we have one question in here. CC, are you still in? I don't want to answer this question if you stepped away. Okay, I'll wait till he gets back. Anybody who's sticking around, have any questions? Cool.
I used before on the company I work a lot of security audits, but not in smart contract world. But they have the same terminology like black hat, white hat, all the stuff.
Mm-hmm.
Um, um, the so goes into smart contract audit. How those good practices you apply here, and if you can differentiate between a black hat and a white hat.
Yeah, so basically saying like how to distinguish the two, what is like kind of like terminology, what is white hat, what is black hat for the people who may not.
Yes, all those stuff. Yeah.
Okay, yeah, that's a great point. Definitely should have talked about that because I know we throw some terms out, and I love that, by the way. If you all hear something, you're like, hey, I don't know that term, or feel free to throw it in the chat, ask the question because that's what we're here to do. So, um, um, so a white hat hacker is basically someone who is an ethical hacker, and what this basically means is you are there to find vulnerabilities in an application and a protocol before bad actors do, which they call the black hat hackers. So essentially, how the model works in the security world is you have a bunch of white hat hackers, or maybe a team of them, and you will have a company who has an application. Let's say they have a marketplace. The marketplace will hire white hat hackers to come and find all the vulnerabilities or most of the vulnerabilities in their application before black hat hackers get a hold of this marketplace. So that's essentially all it is. White hat hackers are the good hackers. Black hat hackers are the bad hackers. And then also there's something called gray hat hackers, which is like in between. And this is like, I don't like to get political or, become hacktivist. I don't want to do it publicly and talk about it here. But basically what gray hat hackers are, they hack for a specific purpose, whether they think it's for political reasons, whether they live in an oppressive state and they're doing it to try to, free whatever it is they're trying to free information, share information, show that people are being oppressed. That's what a gray hat hacker is. It's kind of like that gray area of they're doing illegal things, but they have a motive for why they're doing it.
Hi. Just wanted to bring in the question regarding the same. I've heard people say red team, blue team, green team. What is that
Yeah.
about?
Yeah. So that's a good question. So red team is essentially that's the term that's in the realm of offensive security. So what offensive security is trying to break a protocol. Someone gives you code and they say try to break this, right? That's what red teaming is. Blue team is defensive security. What that entails is someone who's monitoring a network, and Robert can talk a lot about this because he's working on a protocol that does this. Is maybe there's an application that monitors, weird transactions within a system or weird data flows, and they are alerted when someone's attacking. They're like the defenders. And then purple team is a little bit in between and kind of like all of them. They're more like your incident response after an attack has happened. They come in and try to figure out what happened. They may do some offensive security. They may do some defensive security. Purple team is like all of those combined. So yeah, Robert, do you have anything to add?
Yeah, I think another thing just to add to purple team is they also help set up like the monitoring. So even before the incident response, they're setting up like, hey, how do you know you've gotten hacked? Or if in the event that you're hacked, like how can you mitigate the impact of it? So they're also helping a lot in that capacity. Cool. Awesome. I love the discussion. It was a really good. Y'all asking questions really helps us like teach better. So really appreciate it.
I do have a question.
I mean, I like to add something too as far as the red team goes as well. Because red team, the thing I love about the red team is they have to actually put themselves in the position of a hacker. So that could be doing stuff either physically or within the software space as well too.
Yep.
Yeah.
I do have a question. Since I don't come from a cybersecurity background, is there any like places to learn terms to kind of help just kind of have an idea of like when you make those references to kind of help me understand what you guys are saying?
That's a great question. Yeah, I can throw in a glossary really quick.
For me, that'll help just to kind of get an idea what you guys talking about. Like I can, use context, but it really helps with just the understanding of like, okay, red team, blue team,
Yeah.
penetration,
Mm-hmm.
Stuff like that.
Yeah, no, that's a good point. The biggest ones is the ones we actually just covered, because a lot of these are kind of like Web2 terms.
Right.
Yeah, I'll say we'll pretty much just talk, what we're going to be doing is we're essentially going to be red teamers for the most of this because we're going to be auditors. So we're essentially blockchain security engineers, blockchain security pen testers, which is same as a red teamer. So those are the main ones. But I shared a link with y'all if y'all want to like go in through it. It does have some other cool ones.
Thank you. I appreciate that.
No problem. So I think we're going to pause questions here and jump back into it.
Cool. So I think for the rest of the session, at least the rest of the slides, we have a little bit after the slides. It's going to be Solidity focused. So to start, everyone can see the contract on the slide. Could someone explain what this contract's doing? Yeah, someone explain.
And also, just to be clear, like we're all learning this. It's okay to, if you don't know, this is the time in security that we say learning in public, which is you have to be vulnerable and just try. And you never know. This is literally how we approach hacks. So yeah, feel free to come off mute and share what you think it's doing.
Yeah, I'll toss something up. So, do you want me just to read it from top to bottom?
Sure.
Yeah, that works.
All right, cool. So the SPDX license identifier, that's essentially like how you identify. There's like, I'm guessing, I don't want to say standards, but there's certain licenses you can have like to a smart contract. I think like one's like MIT and like there's like an unlicensed one. So this one's GPL 3. And then it says Pragma Solidity. This is pretty much just like, I don't know if it's like instantiating the code, like getting it ready for Solidity. I think this is like declaring the version. So it's like, you can see it's like in between 0.416 to 9, 0.9. And then we say contract smart simple storage. So we're implementing the contract, just called simple storage. And we have a UINT, which stands for unsigned integer, which is any value. It's I think it's 2256. So it's 0 to 250 to 2 to the 256 minus 1. So it's just like a really big number that can't be negative, essentially, called stored data. And you have a function called set, which takes as another uint x, and it's a public function. So this means any contract or any function inside this contract can call it, and you can call it from outside of it. And it sets that storage data to x, whatever you set it to. And then get is a view. It's a view function. So this public view returns. It's important. Like the reason it's view, it says function get public. So same thing, function called get. It's a public, call it from whatever. And then the view is important because we're calling a storage variable. So stored data isn't inside the contract; it's outside of it. So you want to say view, and then returns just tells what's going to return. And since we're it's a uint, just a uint, and then returns it essentially. So it's a contract that sets and gets a number.
Yeah, I think that was a pretty awesome breakdown. Anyone have any questions on this, or like specific pieces of this?
Or any thoughts? Any different ways you looked at this contract or something you thought about? Great job, by the way.
Yeah, that was awesome.
You did better than me. I'll have you to bring you up.
Okay, so if no one has anything else, if you go to the next slide. So I think that was a great breakdown of what was happening. And one of the things I had to learn when I was getting into security is I initially approached Solidity as a developer, so as building. And now we're going to try and focus on what does an attacker actually think when they're looking at a contract? So if you see on the right there's some questions with some arrows. So one thing, always looking at, okay, this contract exists, and once it's deployed, like it has an address, there's like constructor data. Like I'll be asking myself, okay, what is that information? Is it something that I can use? That variable there, is there a way for me to access it without calling that get method? Where is that data actually stored? And like Zion was mentioning, like you see all these keywords. Sometimes during an audit, you're reading a contract and like you don't know what those keywords are, or you've never seen this functionality. So asking those questions so that you can do the research to figure out what they mean. If you go to the next slide. And just to continue that process, it's, hey, they have a uint there. Should it be 256? Because there could be vulnerabilities where a uint it's a uint 256 on one chain, but not the other. And also, I see this get method. Is there another way for me to call this or pass in unexpected data? These are all the questions or the lens that I'm looking at something when trying to break it or create behavior that is not expected. Okay, so before we go into the next slides, we are going to go a little bit deep on the EVM. So it's entirely okay if you don't understand what's happening. I'm happy to talk through like any of these details. And yeah, I just wanted to give that warning. We're going to go into some of the EVM specific architecture. And we're still looking at it with the same lens of, hey, I see this Solidity contract. What does it do? And how can I break it or make it behave in an unexpected way? This is just a deeper version of that. Can we go forward? Okay. So before I break this down, what this is showing here is the execution model of when a smart contract is being executed on a node, like what's actually happening at the EVM level. So before I break this down, there's a few different concepts here, and I just want to see where everyone is at. If you've ever worked with the programming language that has a stack or a heap, and you've been familiar with those concepts, could you put 1 in the chat? And if you have not, could you put 2? Okay. Got a good mix. Okay. So before I go into anything on this diagram, ignore what's showing here. A common pattern across a lot of different programming languages is to have something called the call stack. And essentially what that is that's how the program knows like what order to execute functions in. Um, so if you've worked in a programming language before and you've written a function, this is how it knows. Maybe you have a function that calls another function inside of it. The call stack is how it keeps track of like the order of things to execute. And the heap space or memory is where the actual variables are stored. You don't have to worry about those low level details, but for those who are familiar, um, what this is showing is essentially the EVM from a high level. And whenever there's a transaction with a contract, this is the context that it's executing in, where you have some wallet address or external account or another contract calling this contract with some message data. And it's up to the EVM to figure out, okay, given this message data, what method are they trying to call or what variable are they trying to call? So everything happening in that execution context is answering that question. So in that earlier function, we saw that we were calling like a set method. So the way that would actually execute is that transaction would come in with as a message. The execution context would say, okay, we have this transaction. What method are they actually trying to call? And that's in that area where you're showing the EVM code and the operations. The EVM code is what figures out, okay, here's the function that we're actually trying to call. And the operations are, here are the opcodes we need, like the EVM needs to execute based on this function. And the stack and the memory are, like I was mentioning, the stack is, okay, if they're calling other functions, need to keep track of their order. And the memory is, hey, we have these variables that are stored either in storage or they're, I think in this case, in storage. And we need to access those, and that's where those variables are. So on top of thinking of the contract as when you're thinking as an adversary, you can look at the contract at the code level, and then you can also think about it from the execution context. Because you can get a lot of unexpected behavior by doing things that people don't expect. And there's a few ways to do that if you have an understanding of this execution context. I know that was a lot of information, and I don't expect if this is your first time seeing this, like it's okay. It is very complicated. My first virtual machine was in Java, and it took me a while to figure that one out. But just wanted to expose you to this if you ever run into some of these concepts. So the questions that I like to ask on this level as an attacker are, how does Solidity actually call like functions? Like, is there a way to call a function in a unexpected manner? Given a contract, if you understand the execution model, like what components can you actually affect? Because yeah, it's cool to understand the opcodes, but as an attacker, if you can't do anything with it, it's not relevant. Third question, like what assumptions we can make. And this comes into play especially when a lot of protocols are multi-chain, the assumptions at that low level might be slightly different, even on the same chain. Like there might be some assumptions, especially with like ERC interfaces or the expected return value of like contract calls. So just understanding those assumptions helps navigate finding vulnerabilities. Miles, you want to touch on that fourth one?
Yeah. So, and as Robert was saying, it's okay if some of these concepts are a little difficult to grasp. I just want to go and say, like, I don't come from a development background, so some of these things I'm honestly learning myself. So, a really good one that I started with that helped me at least find those medium and some high vulnerabilities is starting with point number 4. Those external calls, those are pretty clear to kind of tell right off the bat. When we went back to this public function right here, it's an external call. An attacker can definitely call that because it's public. Anyone can call it. And there may be some things that some damage you can do from just that line alone. So if you're feeling intimidated about some of the things we're talking about, just think about it like this: as an attacker, start with something that is you can is more like bite size. You can kind of start with, and I think external calls, access control related vulnerabilities are something you could start today and find some pretty high severity bugs.
If you go back to that last one, to the last slide. So that last point, this is one of the capture the flag assignments is gonna get into this. But because most EVM chains are public, even if you store data as like private or internal, there's still ways to access the actual values that are stored there. That is something that I've seen before where people will keep sensitive information in like a private variable in a contract, not recognizing that that variable is still accessible. Like you can read from it. You might not be able to affect it, but you can read from it for sure. Cool. So next slide. So this slide here is just showing essentially what's happening for the EVM to figure out, hey, this person sent the transaction to this contract. What method are they calling? And like, how do we actually execute that method? So if you're looking at it from left to right, the first thing that the EVM is looking for when you're sending a transaction is if you're calling a function, the function is actually hashed in the EVM just to like save space and make it easier to have more storage for other things. So if you see under the data, there's a function called some function with a couple of parameters, param A and param B. And at the bottom there is what the actual EVM understands that function to be. If you're not familiar with a hash is essentially you give it some string and you give a hash function some string and it spits out a bunch of like what appears to be random numbers and letters. But the reason you do that is if you notice like the number of characters that are used for some function with those parameters is a lot more than the hashed version. So it just helps save a lot of space and helps Solidity be efficient. So the logic process that the EVM does to figure out, hey, we have this contract, we have this transaction coming in, what method are they calling? It's looking for, if you look under the switch selector there, when you have your functions actually in Solidity, this is what it looks like in the EVM. There'd be a bunch of hashes. And it's going to look through all those functions until it finds something that's a match. And if it doesn't find something that's a match, there is a default fallback method. There's a lot of complexity here, but I just wanted to walk through like some of the understanding, some of the things that help figure out how to break things. Like for example, sometimes you can directly call, like you can pass in data into functions that may be unexpected, but instead of calling that function, you just make a generic call to that contract with the like hash function. And there's a lot of different vulnerabilities that have popped up from that. Again, it's okay if you don't understand this. We do have 4 more sessions and we have study halls as well where we're going to be helping with CTS. I just wanted to give a broad view of all the different questions you can ask yourself or different areas you can focus on and try and find vulnerabilities.
Nice.
Cool. I think that was that everything we had for the slides.
Yep.
Cool. Before we
I have a
go,
quick question.
go ahead.
Just a quick question. for this slide right here, I'm just a little curious. The switch selector, how does it know how many cases there are? Does it just like is that like a case of all the hashed functions, all the signatures of all the functions, or is it just like literally every single like address that's possible?
So it's when your Solidity code compiles, that's where it creates that list. It knows all the functions that are inside of there, and it just maps those to a case.
Okay. Okay. And then where could some vulnerabilities come in like with there? Like if you copied like the same function to get the same, because it would all if you just copied that function with the same signature, how could you like I don't know, how could you like exploit that a little bit?
One of the common ones is you see the hash that's created. Are you familiar with the concept of hash collisions?
I'm not, but I can guess, but tell me.
Okay. So essentially, a hash collision is you can have two separate functions where you hash them and you get the same value. And one of the vulnerabilities that comes out of that is, say you have like this function here, you have some function with param A and param B. You can have another function where the name is just like garbage, and it can have like 2 or 3 inputs, but it resolves to the same like function. And so some of the attacks that happen is a contract will be expecting a function to behave one way, where it's like, oh, this function like, returns a Boolean, or like this, it makes an assumption. But someone's able to trick the EVM essentially to say, yeah, this is the function that they're expecting, and have different behavior. And that different behavior can be, oh, I want to prevent this contract from actually being able to execute, or I want to like make a re-entrance attack. So it's just like, this is more of a attack vector, and there's a lot of different exploits that bridge off of this.
Oh, I see. I'm confused. How does that happen though? I thought every like signature would be unique. Like on the name, you know? How does that work?
I think that comes into the, if you see the Keck 256 algorithm, I think the reason it comes up is the EVM only uses the first 4 bytes of that hash for the function. And that's where those collisions happen, where if it uses that full 256, then they're unique, but it's taking the first 4 bytes. And I think it does that to optimize space, because the EVM, like when your contract is running, I think it only has like 24 kilobytes of memory. So they made a lot of optimizations there, and that trade-off is one of the side effects.
I see. That makes sense. I didn't even realize that. Okay.
Yeah.
Cool.
Cool.
Right, we got some more questions. We have, how does call data play into this?
Oh, that's a good question. So if you go back a slide, back one more. So when you send a transaction, all of the data the EVM uses to figure out like what you're trying to do is inside of that call data. So there's a lot of different exploits that come out of that. Like one of them, well, a couple that I've seen. One is, and this is related to one of the CTFs, but you can pass in call data where, let's say you have like a payable function, and it's the only payable function in the contract. And if you pass in call data with like where you send it ETH, and you pass it in with like an empty message, or you pass it in with a function that doesn't exist, you can get around some of the, instead of like, so you could send that transaction where instead of hitting that payable method that the person defined in the contract, you can force it to hit the fallback method or the receive method and cause some things to break. And there's also some other exploits where people can tack on like extra data to the call data. where it's like, hey, this function should only supposed to have like 2 inputs, but someone was able to like manually append some extra bytes to the call data, and it causes some unexpected behavior to happen. So it pops up all over the place, I think.
Yeah, another one is where contracts send call data to. So contracts make calls, and sometimes they don't really verify where this call data is going. So if they don't do that, there's some exploits there. Another one that's at least I'm glad we're talking about this stuff because like I'm learning some of this stuff as we're going. Um, Another one that's I guess that I picked up like right away was or one that leads to vulnerabilities for newbies is call data sometimes returns a success or a failure, and some contracts and some protocols don't even check. They just say let's send a call out and it returns a reply, but some people don't check what that reply message was. So that's another interesting way to look at call data, how contract calls are made, and what are some things that work around it. Um, how can we prevent these actions or reproduce one of these attacks?
Oh,
Yeah,
that
that's
would
a
be
great question.
a good bridge to the CTFs.
Yep,
I could,
I can bring them up.
yeah, I could, yeah, we could show, yeah, we could start going through the CTFs. So part of this, one of the things we really believe at Kit Labs, and also just Miles and I, is there's a portion of getting better as a security auditor where you're learning, listening to sessions, reading reports, but there has to be a portion where you're actually hands-on trying to break into things. So as a part of this course, after every session, we were going to assign capture the flag. It's just essentially homework assignments. And if you're not familiar with capture the flag, it's not a Web3 security concept. It's a security concept. And you can think about it as practice for hacking, where you're given code that has a known vulnerability. It's like very small scoped and a known vulnerability, and you're trying to essentially run that exploit. Yeah, and the first assignment after this session is one of those CTFs, and you actually may have to manipulate call data inside of this one. So I guess before we go through Ethernet, how many of you have, I know we've had some people answer in the poll, but could you press 1 if you've done at least one Ethernet challenge, and 2 if you haven't done any? Okay. So the reason we were asking for what wallet you're going to be using is these challenges are actually contracts that will be deployed on a test net, and you'll be running your exploit to actually hack these contracts. And so you'll be able to go into Block Explorer and see, hey, here's the wallet address, here's like the contract we're attacking. I guess Miles, you can go through Ethernet.
Yeah. So kind of just like go through like the setup for it.
Mhm.
Yeah. So essentially, and honestly, we'll be here to help for anyone who hasn't. So essentially, what Ethernet is like Robert was saying, CTF game. You pretty much have an environment where you can perform these attacks. It's completely legal, so it's not like, oh, I'm breaking stuff. It's bad. Like it's for white hat hackers. This is like challenges for us to learn. So first requirement you need to make sure you have is a MetaMask wallet. I know we have some people who said they hadn't done this before, so make sure you. Let me just go to Chrome. Okay, make sure you download MetaMask, and I want to make sure I give you all the right one.
Yeah, there's scammers out there.
Yeah, there's definitely a lot of scammers. So that's the first requirement is get a MetaMask wallet and actually just do a little bit of research if you haven't already about what MetaMask is, how to use it, the whole nine. And essentially what you're going to do is to set up you connect your MetaMask wallet to this site. Then in each challenge, you're going to have an instance. And what your instance is, and also I just pressed FN F12. This allows you to like access like some developer tools and kind of see some things that's happening on the web page. So what you're going to do is you're going to get a new instance. And you see it's going to go through. It's going to go to my MetaMask. We're paying in testnet ETH. So again, it's just you have to do a little bit of research on how to use MetaMask. But essentially, there's testnet, which is fake currency. This is you're not spending any real money, so don't think you have to like invest to actually play in these games. It's fake money. We're going to get us an instance, and basically that's what the instance address is, the contract that needs to be hacked. So it's going to wait for this transaction to hit, and this is going to return an instance. And this address basically represents this contract. Oh, it just restarted the level. But if you saw, let me go to another level that I already completed. If you saw this right here, let's go to CoinFlip. The instance address represents this contract right here. And that's going to be how you can interact with this address, maybe some of the things that's stored on it. So let's go back to Hello Ethernet. And this is also, oh, go ahead.
I was going to mention, so whatever testnet you're working on, once you have that instance address, you can go on that block explorer and you should be able to see it. So yeah, just wanted to mention that.
Yep. And so we talked through open the browser, and also some of the stuff we're talking about. There's going to be notes here, but also I know for me, I was like, when I first got into this, I was like, I was a little confused on this part, and it's okay. So there's a few things you can do, like get balance of player, which should be yourself. So this returns a promise. So wait. Get balance of player. What this is going to do allows you to do something like how much test ETH I have. So this is how you know your wallet is connected. And there's just a few commands. You can go through this later, but a few commands to help you interact with a contract. And so for instance, you can do things like await contract.info. All right, and so this is basically making a call to the contract that I just showed you. It's making a call to the contract at this instance address, and we just called a specific function in that contract. So this is going to give you hints to how you can potentially break the contract. Essentially, what we're doing is, from an attacker standpoint, you have function calls, you have things about this contract that you need to interact with to figure out how to break it. So it says, and I'm not gonna go through the full thing, but I'm just gonna show how you would interact with a contract. So you go await contract dot, it says info 1. All right, try info 2, but with hello as a parameter. So what a parameter is what you include inside of, let's go back to here. This is a parameter. So this says we want to pass some data into this contract. Let's do one more. Contract info. I think it said info 2. Yep. And then we're going to pass in the parameter of hello. See what that gives us. All right, so we're going to do things to pretty much keep interacting with this contract to try to get to the flag, which is, and capture the flag. That is the thing that gives you points, that says that you perform the attack you were supposed to do. So we're going to essentially will go back, keep going through this exercise, follow what it says, figure out what's going on, bang your head on the wall for a second because you're like, what the heck is this doing? And you just go through this process of figuring out how to break this contract, how to get the, in this case, we're supposed to get a password. So how do we get that password? And something I really want to point out, because I know some people, they're new to security. when you jump into the security space, a lot of stuff is going to be personal research. Honestly, this is and Robert can tell you from a developer standpoint, it's the same thing. You're gonna run into times where you're gonna be very, very confused. You're not gonna know what's going on, and it's gonna feel very discouraging. And this is something that stops a lot of people from continuing down a security path. It's very intimidating, but one thing I want to stress is that number one, you have this community here. You have all of us here. So if you ever feel like you're struggling, just reach out to us, ping us, ask us questions, and we're also going to have study halls every Thursday where we're going to go through challenges, we're going to go through attacks, we're going to be developing all these things together. The second thing is it's okay to hit an obstacle. That means you just have something that you haven't learned yet, that you don't know very well yet, and you will be able to learn it. A lot of security is honestly mindset. It's not even like, being a gigabrain, being a, Harvard grad, all these things. I had no technical experience. I come from a business background, and I was able to land a role at an auditing firm. It is definitely possible to come from somewhere where you don't know how to do this stuff and you learn. So just wanted to just throw that out there because I know a lot of you who haven't been exposed to this yet. This course is probably very overwhelming. But I want to just tell you to get comfortable with that. We're going to be learning this stuff together. And ultimately it's going to be fun. So yeah, that's the first task, is try to go through this CTF. I think, Robert, we're just assigning the first two. So Hello Ethernaut and what's the other one? And Fallback. Yeah. Hello Ethernaut and Fallback. You have this whole week to do it. In our Thursday session, if you have questions, we're gonna walk through this stuff if you need help. But essentially, yeah, you have a whole week to do these two challenges. And one more thing. Go ahead.
Yeah, I just wanted to point out, it's okay if you don't remember what the assignments are now. We have the reason we're asking for your GitHub is we're posting the homeworks on our GitHub repository. And so I'll share that here. And then also it will be inside. If you look at the course material on our website, I'm going to add that there. If you don't have access to that, let me know. The way that the assignment is going to work, every session is essentially going to have its own folder. Because in later sessions, we're going to start introducing audit reports. I'm still filling out these details. I just want to get have the assignment here first. This should be updated by the end of tomorrow. And what we're looking for in terms of submissions of these assignments is once you finish a challenge and submit an instance on Ethernaut, you'll get, it'll let you know whether you passed it or not. And we are just asking that for every CTF, you post a pull request in our repository, just linking either the contract address or the transaction hash where you solve the challenge. And additionally, as we go on, we're going to be asking for people to start trying to write proof of concepts for these CTFs. Because I think the first 7 or 8 you can do all from the console or without having to write any Solidity. But I think future assignments, we're going to start pushing for writing proof of concepts, and you'd also submit that in pull request as well.
Mm-hmm. Yep.
Does anyone? I know that was a lot of information. Miles, did you have anything else?
Yeah, I was just gonna go through, and again, we're gonna have study hall every Thursday. So it's okay if you are bang your head on the wall for the first few days of this. This is the process of being in security is. I guess I was just gonna just do a test one, just so people would see okay, how would I do it? What would it look like?
Mhm.
So we can just open up this one, different branch. Focus.
Oh, yeah.
May have messed up already.
No, I think it's just not letting you
It's
do
not
it on
letting
Max.
me.
We can fix that.
Yeah. We'll have it all situated out, but essentially, as he was saying, let's say I pass this level. We come here. We have the transaction of what we completed. You would just grab this, and when you submit a pull request, if it once it allows me to, then you would just submit the transaction hash. And honestly, I can just go to issues. And
You can make a pull. I just made a branch. Okay. You change the, yeah, there we go.
Perfect.
Okay.
And then pull request. Okay. Yep. So what you would just say is Ethernaut challenge 1 submission, and that's me. And so we'll say transaction hash. And what was the other one we wanted them to put?
So if you, so the ways that you can do these capture the flags, you can do them through the console, but you can also write all these exploits using Solidity. So if you end up writing Solidity, you could just include that in this as well.
All right, yeah. So let's say you have your own repo. I have my own repo of Ethernet challenges. So we can go to my first solution right here. And if you write the code for it, you can say code proof for just code right there. And you would create pull requests. And that's just would be a valid submission. It's just a great way for, this is a free course, but at the same time, we want you to make sure you're engaged. It's just a great way to track, like, hey, are you staying on top of things? Are you trying to learn? Even if, you can say you couldn't complete it. You can just say like, hey, this is my attempt, this is my code, and we can help you out. But this would be the flow of how you would submit something for CTFs.
And this is something also that both audit firms and independent auditor groups look for. If you're like, okay, if you're interested in participating in audits, if you like, this is the type of stuff where you can show, hey, look, I'm doing these capture the flags, I'm looking at these audit reports, I'm doing these competitions. Especially in Web3, just building and learning in public is very much I think it's very like the community really enjoys that.
Yeah, that is a great point. I didn't even think about that. Is you all are building your portfolio with this course. So if you go through this, you have a GitHub full of challenges, all this stuff. It just looks great, and it will allow you to, like, honestly easily transition over into Web3. I did not do this stuff before I joined my auditing firm. It was like a lot of learn as I went, but I really wish I had this course that we're doing, and I really wish I was doing these things to build my portfolio from start. I had one more point on CTFs. Oh yeah, this is a thing that a lot of people taught me whenever I got into the CTF space. It's okay if you spend 15 minutes to an hour not understanding what the problem is. You do have to hit a point where if you're not understanding, you look up the solution. You look up it's something called a write-up. So CTF write-up, Ethernaut. And what a write-up is, it's basically someone who performed the challenge, they did it correctly, and they have the answer. And they're going to take you through step by step of how exactly they did and solved this problem. Something that helped my progression was I had a time frame, kind of like we were talking about audit contests. Like, when do you know when you should clock out? After about 30 minutes to an hour, if I keep getting errors, I'm not understanding, and I've learned, okay, what's going on, where am I going wrong? I go look for a write-up, I look at the solution, try to implement it. But the key to this is after you have done this challenge, you should go back, after 2 or 3 challenges, go back and see if you can do it without the write-up. And that's how you know you're mastering a concept and you're learning things. I think this is something that a lot of people aren't taught when they first start doing CTFs. And this, like, once I learned that secret, it changed how I approach CTFs from there and how I approach my security journey. So that's just the last thing I think I want to leave with you all is that.
Yeah. And same thing. as a developer and auditor, just being honest with yourself and having good like time boxing things. And like Miles mentioned, if you have to look up the solution, coming back to it in the future. But one thing I also like to do is if I have to look up a solution, I will try and do a little bit something extra just to make sure it sticks. So if I look up a solution, I'll be like, okay, maybe I have a solution, I could deploy it, but let me try deploying it with hard hat instead, or let me try writing a test that validates it.
Yeah.
Just like that extra bit to help solidify it also helps.
I like that. I'm gonna steal that one. This is what I love about this course. I learned to do that. That's a great idea. I definitely need to start doing that.
So I
Okay.
think that was everything we had in terms of the session. We still have like if we booked this until 1:30. But if anyone has any questions or thoughts, it would be a good time to transition into just a more discussion open
Yeah.
session.
And really quick, let me go ahead and end the stream, y'all. So that anything like if anyone comes later, they can just come into the chat. But I want to end the stream on YouTube before we do personal stuff.